Hello, operations management students. This is John Robinson, and it's a beautiful morning when I'm recording this, and I just wanted to give you an introduction into how we solve the kind of operational efficiency measurement we're talking about in this section of the class. So I'm going to focus on the assignment for this section. Obviously, these skills could be generalized to other problems that are similar to this, but I think it's most easily applied if we're doing something similar. So, what are we getting at with these operational efficiency measures? This specifically, we're looking for quantitative ways to estimate the efficacy of a particular kind of operation in a larger organizational context. So here in this question one, we are, this is, a production context, right? So there's a certain amount of output that our facility is generating, right? In question one, it's 242.3 hydrospanners. So this is obviously, an average taken over multiple days. A 0.3 hydrospanner doesn't make sense, but, if you measure over a long period of time, or maybe, maybe a shorter sample was taken and then we've aggregated up to a full workday. Anyway, we've got an estimate for the total productivity, total output in units per day. And we're specifically wondering in question one about labor efficiency, right? So there's how productive are labor hours in this facility in terms of hydrospanner production? And so to do this is actually pretty straightforward. We just are looking for production per unit labor, so we're going to take total production and divide by unit labor. So 242.3, so I'm going to head over to, this is just an online calculator that I wrote, but so 242.3, we want to divide by labor hours, was it 5.3, let's see, 5.8, right, and we would get 41.77, now units are key here, 41.78, we're rounding. I'm just going to grab all the digits because why not, but that's not necessarily useful to report all of these. But here we go. So we've got, an estimate, right? This is just, we can figure if somebody has an 8-hour workday. Well, I guess this is hydrospanner per labor hour. So in an hour, so it looks like it takes about a minute and a half, maybe a minute 20 to make one of these things. Obviously it could be quite a bit longer once you include automation, but the actual human labor input into each individual unit at this facility at this time is calculated this way. So we can also, just another way to think about the general purpose approach to problems is to feed it into like a language transformer like ChatGPT. So I'm just going to post the problem as is into ChatGPT. Now, this technology is changing quickly, so by the time you see this video, who knows what the state of the art will be. But at this point in time, these language models are really good at understanding questions you're asking, and they're good at describing a general problem-solving approach, but they tend to be pretty bad at math. It understands it's asking about productivity, and it's defined productivity appropriately, like hydrospanners per labor hour. So it's proposed the problem correctly, and we've got the division. But then notice it actually tells you this has got a bad answer, right? It's close, but it's off by a digit. So this is important to understand what these tools can and can't do. This is actually a really useful explanation for how you get to the answer. But yeah, definitely don't trust the math it spits out, but that's fine. Right? We should be able to do this division ourselves. That's not too hard, and that is exactly what we did do. Right? We look at the calculation we did, 242.3 divided by 5.8. It's just bad at simple math. So we're verified twice, and also I can just hit check and see that this is in fact correct. And there we go. So that's just the base idea here, right? So I've got 242.3 and divide by 5.8. It's really straightforward. Now we start thinking about changes. So this is asking about a productivity increase. Productivity going up by 13.7. So that means we need to calculate this productivity. So we'll calculate it the same way. So 289.3, and then 6.5 labor hours. We'll get a new, right? So now I have our new productivity, 44.5. And so now let's think about what, okay, quite so many digits. All right, so 44.5, that's our productivity. Now the problem says productivity is increasing by 13.7%. Okay, so, right, if you we're aware when we think about percentage increases, that's implying multiplication. Now if I do 0.137, right, 13.7, 0.137, and calculate, we get 6. Now 44 productivity turning to 6 doesn't make sense. So this is actually 6 more units, right? Production is going up, so per labor hour we're making 6 more units. So how do we get it to represent the original productivity and also the change? So that is done by putting just 1. So you can imagine if we just multiply by 1, that would do nothing, which would happen if we had no improvement, right? So by putting 1.137 on there, we actually are getting the improvement. And we can go ahead and share that over into here. Let's check ChatGPT, see if it agrees with our solution method. So it's taking adds the 1, which makes sense. And it's calculating labor hours, which I think it actually did correctly this time. And so there's our, change. So 50.61. Yeah, so it actually ended at, no, it didn't. It's close, but yeah. Not so great at math, this thing. But the setup, right? The setup is useful, helpful, and it's a useful explanation. No shortcut for you doing the work yourself, though. So that's how you would do a percentage change. That's the same in question 3. All right, now we're just changing the... Now we're doing, I guess, the backwards problem. Instead of calculating the change in productivity, now we're going to or instead of using a given change in productivity, we're going to calculate a change in productivity. So for this, I actually also just want to show how one would do these in Excel. So I'm just going to pull up a blank Excel here. Oops. And make it bigger. So given information in the problem, we have, let's see where we go. We have, yeah, I think this is interesting. It opened it up in its own desktop. So let's see if we can get Excel to, here, I'll just go to desktop 1. Oh, we want this one in this list. There we go. I had a lot of clutter in my desk, so I was trying to have a clean thing for the recording. So we've got, what have we got here? We've got 139 per day using 11 labor hours per day, right? So 139 and 11. And then we're going to have a new one with labor hours decreased by 1. So 139 and then 11 minus 1. So we can calculate a productivity here, right? Here's the productivity here. And here's the new productivity. And this is the improvement, right? So here's the improvement. So I think the problem is asking for what is the percentage change. So that would be change divided by is it new or old? Is it new or old? Percentage change, percentage change. If I am I think it's new, but let's see if ChatGPT can bail us out. So let's see if it has an opinion about this. Okay, so it's going with we got a productivity, and then we can get a new productivity. Yep, great. New value minus original value divided by original value. So old is the answer. So let's fix. So it's like, that's one thing that's nice about Excel is you leave an audit trail, and we can just adjust like that. Oh, let's get some more digits on there. Wow, 10%. That makes sense, right? We just took 11 hours to 10, so that's a 10% change. And we'll see if it likes us. Percentage change in productivity. No. If labor hours decrease by 1, is percentage change in productivity. Let's just try new, see what happens. Oh, wow, that is not right. Okay, hold on. And now that's backwards. Struggle bus here. Okay. Oh, it could be. It also could be. Maybe it's like this, right? That's probably. There we go. Oops. Yeah, and I bet you 9.091 is a failure. Yeah, we'll just stick with 10. Okay. So there we go. So be sure you divide by difference, change, right? Divided by old. And sometimes productivity gets worse, right? So if labor hours go up, productivity goes down, then you'll have a negative number. That's fine. Expressed as a percent. 5 is similar, and 6 is a straight one. Now, 7 and 8 are multi-factor productivity. So multi-factor productivity is when we have multiple inputs. So you can imagine having labor and materials. Well, that's going to force some kind of equivalency between those two things, right? It doesn't make sense to say I reduced labor by 1 and materials by 2, because labor might be measured in hours and material might be measured in kilograms. Well, those aren't the same units. It doesn't make sense to do. So what do? For multi-factor productivity, we're almost universally working in dollars, right? So if we need to do the dollar equivalent labor and the dollar equivalent materials, and then we can figure out production per input dollar. So I'm just going to go ahead and copy this into Excel, and here we'll just paste it in here. Oh, all right, go like that. Oh, let's see, multiple lines. Oh, wrap text. There we go. And make the font a little smaller so we can read it. Okay, there we go. Okay, so we have 158.1 using, all right, so this is output. Output labor hours is 9.6. Mats materials is 7.2. Overhead is 7.7. And then we've got dollars per hour, right? Dollars per hour, 980. It's an old problem. You can't get Subway for that anymore. All right, multi-factor productivity. So we need to figure out the total dollars in, right? So total dollars in is going to be labor hours times dollars per hour. And then we have dollars of materials and dollars of overhead. And then we can add those up. All right. So now we have total dollars. So what's our output per dollar input? This is straight division again. 1.45072. There's some extra numbers. Oh. Okay. Now let's check. Let's do the ChatGPT check. See if we can do math. There we go. So, right? So we want to have the different factors in the denominator. And it understands it needs to multiply and add. And once again, gets the wrong answer. Well, does this work? Correct, right? So bad at math, but good at explaining what you might do. So, so yeah, that's it for homework assignment number 1. These other ones. Oh, okay, this last one. I'm going to leave it to you to think through, but this is the percentage change. So you're going to combine two things, right? So you'll do multi-factor productivity once, then you'll do multi-factor productivity again, and then do percentage change. So, so yeah, I know. At this point, many of you are already through the assignment, but I know there are a few of you still working on it. So hopefully that's helpful, and I will have later do something for next week. So awesome, thanks. I hope you're enjoying the class so far, and I will talk to you soon.